this is an experiment. This whole session is, I guess, a session, akin to 10 years of frustration in dealing with site terrain and how much energy and effort's required to actually generate a survey. So I brought along my trusty surveyor today, and Liam from Bennett Bennett. But I guess he'll kind of go through some details about himself and Bennett Bennett shortly. But let's start off, I guess, what we're going to try and cover in the next 40 minutes, which I'm supposed to this time hit a timer so that I don't accelerate too fast or go too slow. There we go. So I also want to talk, just to give a brief introduction about this topic and why I think it's actually important. Then Liam's going to talk a little bit about himself and Bennett, so you get a better understanding of where he's come from. He's going to talk about the processes and technology that's used by surveyors today, because I think the biggest challenge is that in any of these environments, we actually don't communicate with our collaboration partners to actually understand how they work. And it's only once you have that opportunity to sit back and go, how does this person actually work at their end, to then be able to ask the questions of them to actually get better information out of them that makes your life easier. So we're going to talk, then Liam's going to talk about different survey information needs. So you use surveying for different purposes. Then I'm going to talk about the different ways about a way you can import these different processes into Archicad. We'll talk about the side-by-side results. Then I'm going to show you a little bit of an experiment where I think that we might have cracked the nut finally. Then Liam will close out in terms of covering some final options, and then briefly touch on methodologies of which you could go to a surveyor to actually specify and asking for these information requirements. So what I'm going to do is hand over to Liam, and he'll take you away from here. Oh, actually, no, I'm jumping gun. I'm giving away my introduction. So, the biggest problem, I think, well, there's so many biggest problems. I always say that every time I stand up on the stage, but one of the biggest frustrations I have at the start of a project is when we have to model the site terrain. Typically, we're receiving a DWG from our surveyor. We sit there, we take that into Archicad. Depending upon how the DWG is created, we'll possibly even trace the lines and then get our mesh tool, put it on our site boundaries, and then go click, 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 and add the contours to the mesh. After we've added the contours to the mesh, we end up having to elevate every single one, which is a ripe old frustration. Now, the problem is the amount of time this takes on every single project. It varies from my perspective between 2 to 3 hours to a whole day. That's a lot of energy for no benefit, right? So essentially, it's costing you a lot of money to generate this existing terrain for what I perceive as not actually any financial benefit at all. You should be spending time doing things with regards to architecture. Now that I've got my rant out of the way, I'll hand over to Liam.
Cool. Right, hear me all right? All right, so yeah, my name's Liam Thierens from Bennett Bennett. We're a Queensland-based surveying firm. Offices based in southeast Queensland. We do work nationwide, but that's sort of our focus. So a little bit about myself. So yeah, I'm a surveyor. I'm registered with the Surveyors Board, but I do specialise in the spatial services, which is laser scan, photogrammetry, using aerial and terrestrial platforms, typical deliverables, details, as constructed surveys, 3D modelling, spatial data, sort of the digital engineering and BIM type projects. So that's my expertise, but I do all surveying. So we'll touch on modern day surveying. I guess the typical survey equipment that people, really all survey companies use nowadays is there'll be total stations, measure angles and distances to coordinate points, levels to get really accurate heights, and GNSS, or as some people call it, GPS. And so they're sort of the typical tools that almost all surveyors use. Nowadays, and I guess over the last 3 or 4 years especially, laser scanning and photogrammetry has really taken off, and I guess 5 or 6 years ago, there would have been probably 5% of survey companies doing this sort of stuff, and now it's probably over 50% are doing it, and we get it on at least 50% of our projects. Our clients are asking for those types of services. So a little bit about them. Laser scanning, LiDAR, it's actually the same thing. LiDAR is light imaging detection ranging. When people think of laser scan, they think of a scanner on a tripod. People think of LiDAR, they think of it, a laser scanner attached to a plane. It's all the same technology, it's just different applications. And photogrammetry is essentially stitching pictures together. Good. Nowadays, drone surveys. Well, drone surveys are most of the time using photogrammetry. So it's just taking lots of images, stitching them together to create a 3D model. And so both laser scanning and photogrammetry are from terrestrial methods. And one point that I wanted to make is really all surveyors work in 3D. As a standard, our files are 3D. And we do get a lot of clients ask for 2D, thinking that they might. Actually not any easier. It's flattening our data and sending it out. So it's surveying, applications, laser scanning, detail surveys. Essentially, we might laser scan areas because they're difficult to access, complex environments, to model, things that really would require a hell of a lot of field time. So essentially, we're doing a lot less surveying in the field and more on this nowadays. I'll touch on some of the outputs that we can get from these types of surveys, but I'm pretty much just trying to show a few applications that we're doing in modern day surveying. Scan to BIM, many would have heard of this nowadays. It's essentially laser scanning and subsequent 3D modeling. And so that's essentially, and yes, we're Revit users, as pretty much any surveyor. I'm probably the only one here, and I'm going to be very unpopular showing Revit there. I'm just showing one of the applications we're doing is embedding things like true view, panoramic imagery and things inside of these files. We have this week found a workflow to get it into IFC files for Archicad. Made this video beforehand. But these are the type of deliverables that you can really maximize nowadays. So I mentioned, so that was laser scanning. Photogrammetry can be done by, you can use your iPhone, just take a lot of photos, stitch them together, create a 3D model, or you can use, high-end digital mapping cameras and things like that. One of the really has taken a huge step over the recent years with drones, and almost all surveyors have a drone in their toolkit to do these types of surveys as well. So different survey information needs, things to consider when asking for a survey. We will go through a brief at the end. Cadastral boundaries are always important. If you're building close to the boundary, the secondary interests, or you're doing a lot reconfiguration, cadastral surveys are required. Sometimes they're not. You can just get away with just a standard detail or contour survey. Did want to talk a little bit about the difference. A detail survey is essentially getting all of the detail surface features on site. A contour survey might just be topography, so if you are demolishing everything, you might not actually need everything done. Measured building surveys, that's obviously the internal measurements, which nowadays we do mostly with scan to BIM. Underground service requirements. There is actually subsurface utility standards associated with that we survey to. So obviously we can go to mapping every single service underground 3D to the centimetre accuracy, but sometimes you just need an indication. It's not always required. accuracy requirements. Often we see on briefs by other consultants telling us the accuracy that we need to meet on a survey. And of course we can almost always meet these accuracies, but it's always about weighing up the cost associated with that. Do you really need 5mm accuracy on a open sports field that's going to be ripped up anyway? So it's just something to consider. And will an aerial survey be sufficient? You might be able to save a fair bit of cost on the early phase of the project by doing it by a different method. So I'm going to hand over to Nathan now to go through the brunt of the presentation.
So when we start with this process, you've got to think of the different ways in which you can bring information into Archicad. So we're experimenting and identifying the different methodologies that users can take to generate a site terrain. So moving away from the standard approach where users are going and tracing DWG drawings, you can bring in XYZ files, and I'll talk about those and the problems with those in a minute. E57 or a point cloud file format, IFC format. Photogrammetry can come into Archicad as a 3DS file, which converts into a GDL object, and then using processes using Grasshopper and Rhino. Oh, it's all right. The video hopefully will work. So the key thing is that I'm not going to go through all the processes in 40 minutes. It's going to take a long time. So I encourage you to read the handout. There's step-by-step guides on how to import these file formats and get a terrain output, okay? So if you want to see that and the step-by-step, go into the handout and you'll be able to actually achieve it. So what criteria, so we always look at what's the outputs that we're trying to achieve. So what's the criteria that I'm wanting to achieve in a terrain? Well, first of all, how long is it going to take me to create? Because that's time and that's going to cost me money. What's the graphic output in plan? Do I end up with contours? Will contour lines be in plan? Secondly, graphic output in sections and elevations. Am I going to achieve a solid appearance rather than having a single line plane? And the rain's coming down big time now. The ability to actually interact with this actual element that's been created and modify it and change it and actually be able to do things to it. Attribute management. I keep banging on about attributes, but attributes also can be affected through this import process. Polygon count and the load on your software, because the last thing you want to do is actually load something into your file, build this terrain on a site that you're working with, and actually have your file perform poorly from the time you actually start working on it, and you're starting on a bad foot already. But most of all, I think the most important component of all this is accuracy. Now, when a surveyor goes out on site, and in the past they used to go around with a dumpy level and take points at places where they thought it was very important to achieve the level of accuracy that was being requested by the architect at the time. I think that's right, isn't it? You'd make the educated decision as a licensed surveyor to say, I need to get levels at these points. Now processes have changed, and you can do things differently with scanners and all that sort of stuff where that then calculates those things. But you want to achieve accuracy. You want to achieve the accuracy that you've actually asked for in the delivery from the surveyor. So let's look at those in point. So XYZ files. Let's look at the positive of an XYZ file. It's very quick, right? And it uses the native mesh tool. So you get appearance and section, and you get no additional attributes. So it's using what's already built in Archicad. Now, the big failure is in XYZ. There's no contour lines, it just generates a plain old mesh. There's very high inaccuracy at break lines, and I tested this workflow a decade ago and told Graphisoft they should pull this whole feature out of the software because of the potential danger of this and how people will just say to a surveyor, oh, can I have an XYZ because I've got that feature in my software. It's going to work really, really well. But I'm going to show you in a live demonstration in a minute actually how bad it can be and how you don't want to use this at all. Now, this is a diagram that got given to me from a surveyor that I tested this with a decade ago. I had to pull it out because I thought I've got to try and explain why there's a problem with this. So what you have over on the left-hand side there is the points the surveyor has selected to take. Now, once again, this was before laser scanning. This is when they went around and did the point by point. So he's taken those 13 points, and when an XYZ is imported into Archicad, it just puts the points into space. It doesn't do anything more than that. It has no more smarts. It's only an XYZ in a text file. It says, I'm this height in this location. But a surveyor works in triangles. So each point has a relationship to 2 other points as a minimum to then generate and create a true terrain. Now, people can test me all you like on this, and we talked about, okay, well, if we wanted to stick with XYZ as a methodology because we're going to use native mesh, can we just increase the density of said points to reduce the inaccuracy? Now, once again, I'll show you an output that comes directly out of a surveying piece of software where it has generated this XYZ by algorithm, because it's determined that's the right methodology to do so, in comparison to an IFC export. It's quite scary, so please do not use this methodology. So, a point cloud. So point clouds, in my view, are really, really powerful for capturing existing conditions, because the majority of projects that I used to work on were located in remote Queensland. So if you missed a dimension, you'd have to travel for 2 to 3 hours via car to site, take the extra dimensions that you wanted, and then drive back to the office. So you've lost a whole day, potentially, of time in capturing these things. So a surveyor, when they go out on site, can use their scanner, capture all of that information. Once again, it's a time saver for them as well, because you could at the start say, you know what, I only need this information. Now, point B, if you ask for a certain level of accuracy and the level of accuracy that you want increases, that can cause a problem with scan times. So it would have scanned at a certain speed, which takes a certain amount of time. If you said that you wanted to increase the accuracy, that could be a problem. But what that can do is they can capture all of the information within this space. If you ask for it, then you ask for the plan outline and the heights, but then you go, actually, I want to know exactly where that duct outlet is. And they can go back into their data and pull that information out for you. So it's really powerful for that. As I said, it's a high level accuracy. Depending upon the material that you're hitting, the accuracy changes. So gloss, no gloss, and reflectivity and stuff like that. And it's actually a really good process for checking as-built conditions. So as I talked about this morning, moving forward, clients are going to want more information, more accurate information about what's been built. This is possibly a process that may be utilised at the end of construction. The other positive is there's no additional attributes. Yeah, I love attributes. I should get a t-shirt on that, but anyway. But the negative is that you still need to model or trace the elements. Okay, so this, as a point cloud, I'll just make sure I got it. No, it's all good. So I haven't got it. So when you put a point cloud into Archicad, when you're working natively within Archicad, you can see the points in plan, in section, in elevation, and in 3D. When you publish a PDF, or when you save a view onto a layout sheet, none of that information actually carries through. So you actually have to model it. Now, there's no way in the world I'd try and model a terrain from a point cloud. Some people might be crazy, but it's not my kind of, it's not going to save you time. The problem with point clouds, because of the level of number of points that it's picking up and the accuracy, the files can be extremely large. And for people that are not experienced with point clouds, when you open up a point cloud into an Archicad file the first time, it can be very overwhelming, because the level of accuracy there is what can scare you. Because you see this wall and you design the wall and you go, well, that wall was designed with a consistent or a constant radius of a certain value. And then when you go to model it, you'll see that there's actually inconsistencies in the depth of the plaster, because they've skim coated it to get a nice smooth finish. And the radius actually changes throughout. So you've got to get over the mindset of the accuracy that you're going to apply to it, and what's the relevance of the accuracy that you need to apply to it. to actually get a built outcome. IFC. So 12D is the software package that a lot of surveyors use here in Queensland. I don't know what the take-up is in the southern states. Is it about pretty high still? You're off, because I don't want any feedback.
It's still high.
There we go.
Yeah, it's definitely, even not just by surveyors, it's the most common
For civil engineers
package,
as well.
Civil package in the country.
So their software can export an IFC tin, which is a triangulation file that they're working with, which is the format that surveyors work with and civil engineers. That's the level of accuracy that both of those work with. Now, the workflows, if you develop a workflow using IFC, you can not only capture the information from the surveyor, but you can also then take the information from the civil engineer and their bulk earthwork levels and bring that into your file as well. So it's a kind of a double banger winner. Existing buildings in IFC format is most useful, but what you're going to find with that is that you'll have to have engaged your surveyor or another party to have converted that IFC file, the point cloud into an IFC file, but also show you another software tomorrow that can automate that process or part of that process. The other positive about IFC is the format actually holds information where all the other formats don't. Well, actually, I lie. Sorry, a point contains RGB information on top of its actual location, but it can hold information applied to it by a person that's providing a supplier to you, where it can actually add information explaining what that actual element is. So the failures of IFC, attributes can pollute your project file. So when you use IFC translators, make sure that you have a translator set up to map the information coming in so that you don't end up with stray attributes. Okay, that's the first kind of thing. IFC, and this is kind of across the board, IFC as a schema doesn't contain symbolic floor plan information, so it's not going to present itself graphically potentially how you want it to. And at this point in time, you can only kind of get a plane on, not a solid. Now, there were some tests that we were able to do on Monday where we were able to get a consistent depth that followed the profile of the site, but not taking the site from its terrain level down to zero. So that's an area where it's a bit of a problem, which, in an ideal scenario, you could do that, get that file with the plane all the way to the ground as an IFC, solid, straight into Archicad, no other problems, no other tests. But you don't get contours, once again. So you're trying to cover all your bases. Photogrammetry in 3DS, now this is exciting. I nearly killed the computer using this. It's useful for master planning and concept planning. So as Liam mentioned, they can turn around and send a plane up. Well, they could even you can actually pull data from the national DIS information. So they actually don't even have to send a plane up to capture existing terrain and buildings that surround your site. So therefore, you can actually, in a master planning stage, ask your surveyor, can you give me this information in a 3DS format so I can import it into Archicad. So it's actually quite useful for the early phases. No attributes get created in this process because you're bringing in a 3DS and converting it into an object. And it is solid and it can be seen in drawing outputs. So that's a big positive for it. Now the negatives behind 3DS is the number of polygons it can count, or the number of polygons it creates. And that can be a problem for a lot of users. The textures, so this format can hold textures, but sometimes it can actually lose its texture. And I guess this has a benefit of being able to hold textures where IFC doesn't hold it too. So that's something to be mindful of. When it's converted into an object, its selection is based on a bounding box. So you get points in the corner, and I guess at the same time you can select it through having the magnet turned on, but you can't actually select the faces of the object, unlike with the other methodologies. So let's put them all up on the board. Speed of creation, you can see here that, I kind of voted against the point cloud a little bit because of the fact that you're going to have to do some work to it to actually get it to be meaningful for you. In terms of contours and plan, none of these actually deliver it. So it actually means that the best methodology still is to bring in a DWG and place it in your file. Solid in section, we've got a mixed bag. So we have our XYZ and our 3DS. Ability to interact with, I guess the XYZ file actually is probably the easiest one to interact with. You could argue that the IFC, when it's converted into a morph, actually has a similar capability. Attribute management. Your point cloud and your XYZ don't cause you any grief. Your IFC won't cause you any grief if you set it up properly. And I think I gave that the wrong mark, but we'll move on. Polygon count. The XYZ, you're just going to be careful depending upon the size of your site. Point clouds are very dangerous because Archicad can only handle 4 GB files, I think it is. Point clouds, it's 2 or 4, I can't remember the magic number. So you need to use a decimator. Here we go. 4. Yep, 4. Yeah, I got the number right, I'm glad I did. IFC should be right if people are modeling correctly, and 3DS can be quite dangerous. But then the accuracy. So under the accuracy, we can see here, obviously, XYZ I don't believe has any accuracy whatsoever. And we can get great accuracy through these other methods. And through the photogrammetry methodology, you can get good accuracy, but it comes at a price when it comes to speed in terms of load on your software. All right, so 10 years of pain. I kind of want to take a pill that essentially makes all these pains go away and essentially solve all my surveying and existing site terrain problems. And, you know, I started on the journey because 10 years ago I was given a file from this surveyor and I kind of thought to myself, you know what, I want to try and come up with a solution that embraces this XYZ approach because it doesn't cause any issues with attributes. It doesn't create all, it's the most kind of native way I want to work, right? But the problem being is that in that XYZ format, you lose the accuracy. So we go on and we move on to kind of, let's experiment. And that's what the fun and joy of all of this is. It's taking lessons learned and going and seeing how you can do things better. So we're going to mix up a few processes. And, you know, let's look at this XYZ, right? So the accuracy is the issue. The polygons is contours and plan, solid and section. So they're the type of things that I want to achieve in this exercise. Now, we started this experiment using this process, but the process was a 9-column text file. And what I mean by a 9-column text file was to align with the triangle file. So what we're doing is capturing each of the individual points and saying what its relationships were to 2 other points and essentially recreating a triangle file. Now, the surveyor must have gone to a lot of effort to try and create this because all the discussions with Liam is like, we can't get this out. It can't actually be achieved. Now, John Merchant from Geometry Gym, about 12 months ago, I think would have been, we come up with an experiment where we pushed that 9-column file. He took it, put it into Grasshopper and essentially generated the nice terrain for us and demonstrated that it worked. So I've gone, all we need from our surveyor is, Liam, just give us this. And my problems are solved, I'll get this file in and we'll be able to push it all in, but alas, we've got no chance. So triangle file, fail. So we got no chance with that working. So the route that we've gone down now is IFC. The reason for that is because of the accuracy side of things. And I better just check because I don't want to overstep the mark and say things too quickly. But working with John Merchant, we've kind of worked through methodologies and he's the brains in terms of actually being able to put Grasshopper scripts together because I couldn't do that to save my life. But we're trying to achieve accuracy and polygons here. Now, it means that we have to rely on morphs because out of Grasshopper, to try and achieve this complex geometry, the only way we can get it out of Grasshopper is as a morph. And you know, we could take the approach. So I look at the way in which we could have achieved this whole scenario. So as I talked about previously, and that's not good falling asleep, but I talked about if we get this IFC, we get a plane. Now that plane, you could import the IFC into Archicad. You could then model your terrain as a solid slab or something solid. Then use that IFC, which is converted into a morph, to become a solid element operation with an upward extrusion. therefore generating your solid terrain. Then you have to bring in your DWG, lay over your contours, and then mark up your drawing as you see fit. So that's kind of the first approach. The second approach, I guess, is where you could be taking the approach where we did and only do half of the kind of output, which I'll show you in a minute, whereby you start in Archicad, you've performed that solid element operation, you then take that geometry and push it into Grasshopper, and then write a script to create your contour lines. Now there's a YouTube video that was released from someone out of Denmark, a PhD student that is currently experimenting with XYZ Files, and I've kind of cringed when I saw XYZ Files because of the way he was doing it, and generating contours from Grasshopper. So his approach was to create contours using the line tool, whereas my approach is, well, let's actually create contour lines as morph lines. Now, why would we do that? Sorry? Well, that's one. There's one other important point. Associative labelling. I can actually label each one of my contours now with an associative label that says it's RL. And it's not going to be wrong, it's going to be what it is. So you can't, no more typos. So that's one approach. Then the final approach is I only like doing things once, I only like doing things in one way. So John has been able to create a Grasshopper script which takes in an IFC file, which is the plane. It takes that and creates a solid mesh down to 0 and creates morph lines. So it gives me the accuracy that I need, it gives me the solid that I'm after in sections and elevations, and it gives me my floor plan contours. So it's quite exciting, lots of fun and games, and let's see if we can break it while we go about this. And we're going to be out of time almost. So let's see if technology works, and it will.
You take the time.
So I'm not going to go into detail about the script specifically, but at the end of the day, what we have here is an input of an IFC at the start that's been created at a 12D and exported from Bennett Bennett. So this is a replicatable example. We come down to the end, and right now I've got this all turned, it's not connected to Archicad. So at the bottom end here, I've got a morph, which is a morph solid, which generates my terrain in 3D. And at the top here, I've got my morph curves, which essentially set out all of my contours. Now, I'm going to open a blank file, and we're going to connect this to Grasshopper. Now, I've cheated a little bit because of the story settings. So this is a out-of-the-box international version of Archicad 23. So what we have now is our mesh, which is a morph, and we've got our morph contour lines. So in 3D, we'll explode out. That's how it is. Now, just to give you a bit of context, this is what an IFC looks like when we bring it straight into Archicad from the IFC file that was created. Now you see here there are some holes in here. So John cheated a little bit and helped cover that, write some script to kind of cover in some holes that appeared in the middle. Now you can talk to your surveyor about whether or not he is willing to put a plane in where existing buildings are, because obviously not providing information in those holes means that he's saying that he hasn't measured it, so you could take that approach. But what you can see here is what we have is an output straight from Grasshopper. Now, let's see if it's going to behave itself. And I want to now do the XYZ methodology. So just remember, when you're looking at this, actually I shouldn't do this in 3D, I should do it in 2D just so it's a bit neater. But I want you to observe where the boundary of this this IFC mesh is that's been placed as a morph. So I want you to observe where the edges are. That's the first thing I want you to see. So let's go to interoperability. We're going to place a mesh This is an XYZ, pure XYZ file. Because we've received it from a surveyor, we're in meters, because they like it, and we're going to put it in its original location. All right. What's the problem, first of all? So based upon the XYZ coordinates that are part of that file, it's determined. Archicad said, well, I've got a point here and here, so I'm going to, or I've got points in certain locations, so I'm going to fill the gaps. All right, so it's missing bits. But this is the more entertaining part, and this is the reason why you never use XYZ. Yep, that's all right. We're going to do that later. So what we want to do, and normally I put this over the other IFC file. Now, the XYZ, because I don't like it, I really detest it, let's make it red, and let's make it a plane. Now, because of its approximations and its estimations, look at the difference between the accurate IFC and the XYZ. Now, I just looked, when I first did this is the pillars to the commissariat store, just down the road, across the river, accurately provided by a surveyor and essentially decimated by an XYZ process, okay? So it's something that I completely, basically think should be thrown to the bin. Now I've deleted that. But the other benefit that we have now is, and one of the things I didn't touch on with John's script is, depending upon the size of your site, I can control the contours. So if I want 500 mil, and it's better to click on this because my accuracy in clicking isn't that good, we'll go back in to this file here. And because I've live linked it, it might behave itself, but we'll just double check I didn't kill the connection. We'll see that we are going to have obviously the additional contour lines. Now, why is this also a benefit? So we're going to go to our labels, and I'm just going to turn off the label header. And because it's still working, it's going to be a bit slow and cranky at me. But let's just click on this morph. And it's going to... I'll fall asleep before I can select this thing properly. Let's just... See, my computer's saying it's too late to work. Anyway, what we'll do is we'll just be cheeky here, even though we have... It doesn't like having all these Archicads open. Thank you. So now what we're going to do... Oh, ha 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 ha. All right, we're playing a game now.
Live demos, that's it.
Oh, live demos are my favourite. But in any case, just don't change on me again. Thank you. No. All right, one click and we'll hold and we'll wait half an hour. No. In any case, you understand the point. At the end of the day, you can go in there and height from sea level, write dumb text RL, height from sea level, and associate that label to each one of your contours as you see fit. So from my perspective, I kind of look at that and kind of go to myself, yes, you still have to bring in a DWG to put some lines out there, but you could potentially push this experiment even further and get to the point where you can say to the surveyor, you know what, I only want you to send me the curbs in this IFC file. I only want you to send me the road in that file. Then you can materiality drop each...
Separate the pavement anyway.
Yeah, so you can separate everything as separate files, and then you basically duplicate this process down on the work page of your Grasshopper, and essentially bring in each individual bit, put them on separate layers, and all the lines are then created because they have their own bounding edges. So it's a pretty spectacular potential way of working. And as I said, it's highly experimental, so don't sign off saying it's the only way in the world to do it. So I'm going to hand back to Liam to close out the presentation. And you are live.
Yeah, so look, I won't be too much longer. I was more just going on alternative survey deliverables, things that you might not have sort of dealt with before. I mentioned before that sometimes an aerial survey is actually all you might need on a job. It's very easy to get a copy and paste survey spec on a job, but often if it's early phase of a job, maybe an aerial survey would do. Whether it's a manned aircraft or a drone, they're both viable options. Depending on the accuracy requirements. Often they are less than half the cost of a ground survey. So it depends on the scale and the area, but it's something to think about. And it can contain a lot of contextual information outside the site. Depending on the job, LiDAR or photogrammetry does make a big difference. If you are looking for the accurate ground surface, then LiDAR is always the way to go because it does actually penetrate the vegetation to get the true ground surface. With photogrammetry, we'll purely just get the top of whatever surfaces you are, but they're never as accurate as a ground survey. So it's weighing up that sort of cost versus accuracy. And typical deliverables will be orthographic imagery, where it's super high-res imagery. Sometimes pixel sizes around about sort of between 1 and 5 centimeters. I think the one that you're looking at here is about 2 centimeter GSD, and it's all to scale. It's all horizontally. This one's about 50 mil accurate, so you can actually we can actually supply a CAD outline, so you can import this in, draw over it. We've actually scaled this one here for South Bank. You can actually see where we are on this one, where that's all just done by aerial survey. And delivered as CAD. And other survey deliverables you might have seen before, 3D services, and even without using laser scanning or anything like that. Often surveyors, when they are picking up underground services, we are getting attribute information, depth, size of material, materials, and all that. And we can actually create 3D objects from that. Sometimes we laser scan them and things like that. And street furniture, light poles, street lights, and all that sort of stuff. So that's sort of type of deliverables that are on offer as well. Can be delivered via IFC into Archicad. And 3D trees and things as well. We've done various things for all sorts of projects like that. So conclusion, briefing a land surveyor. Look, we could give you a run-of-the-mill survey spec. Often we do reverse brief on surveys, but key things to consider, purpose of the survey really helps if we've got a little bit of background on why we're doing the survey, what the end product is. Because often we can provide our experience of what might be the most suitable spec. Clear area of interest. The amount of times we get a very, very vague area of interest and you didn't get the next door building, you didn't highlight it. Bane of my existence, clear area of interest. Cadastral survey requirements, obviously we're happy to provide advice on that. Underground surfaces, as I mentioned before, there are sort of certain standards and specifications related to those. Particular features or areas of interest on a job. Often, we can survey the whole site to a certain spec and then really get more detail on certain items. How accurate do you really need survey? So as I mentioned before, we don't have to do this whole accuracy. You could be like, look, I need the finished floor level to, really to that millimeter level, but on the grass I only need sort of that 30 mil or something like that. Often we don't actually get told by our consultants what software they're using. So if we actually know that you're an Archicad user, that helps. So it's obviously a large portion of our clients are Autodesk users, but if we know you're an Archicad user, we can provide deliverables that obviously more customized for it. Do you need 2D or drafted plans, PDFs? Essentially, like everyone, creating these plans do take time. As a standard, like if you don't need them, we won't do them. We can save cost without them, but obviously I know that a lot of jobs, clients like them. And get your surveyor to give you a reverse brief. Even if you give a survey spec, I think it's always a good idea that a surveyor reverse briefs back to you to make sure that they've read and understood the scope. That's it for me.
So thanks very much, Liam, for your assistance and persistence in dealing with my kind of craziness. And as I do have a craziness, that's the live example of a label.
Oh, it worked.
So I got it to work, but you know, it had stage fright. So one key thing is that we are behind time because of all of the things. So remember to do your CPD questions and fill that in if you are chasing your CPD. Otherwise, we'll take questions and have a chat during the break.